Vectors using law of sines and cosines. The magnitudes of vectors a and b are given, as well as the angle between the vectors. Find the magnitude r of the resultant and the angle the resultant makes with vector b. Here we have our x and y coordinate. We're always going to start in the standard position, and we're going to go 136 degrees. I'm going to call this vector b, vector a. Now our magnitude is going to be somewhere in between these two vectors. So we want to find that length, and then we want to find the angle that makes with vector b. So we want to find this angle. Whenever we're looking for an angle, we're usually always going to want to look at the standard position and then go to the angle to the resultant. What we're going to do now is we're going to make a parallelogram out of this. So this length matches with this length along with this one. Let's look at angles now. We have two lengths. We don't have anything else of this triangle, so we need one more thing. So we can find an angle actually. So this whole angle is 136. This angle is 136. So this angle in here is 180 minus 136, so 44 degrees. Okay, so we have 44 degrees. If you want me to redraw this triangle, we have the r that we're looking for. This is 44 degrees, 1.85, and 2.06. So what we're looking for is this r and this angle. Now we can use the law of cosines and sine that we have been taught. So you're given a side angle side. So that means you can set up law of cosines. We have r squared equaling 2.06 squared plus 1.85 squared minus 2 times 2.06 times 1.85 times the cosine of 44 degrees. Take the square root. Your r length should be 1.48. And then we need to find the angle, so now we can use law of sine. We have 1.48 over the sine of 44 equaling 1.85 over the sine of theta. Cross multiply, divide. So it's going to be 1.85 times the sine of 44 divided by 1.48. And then take the inverse sine of that. We should get about 60.3 degrees. And that is from the standard position, so our answer would be 60.3 degrees. So here's just a visual. This is what we did in the other lesson, and this is what we're doing in this lesson. So we have our vector, and in between is going to be the magnitude. Okay, so we want to find the resultant in each of the following sets of vectors. So in the adding and non-perpendicular vectors, that's what we did right here, is we added them to get your x and y, and then we converted it back to our vector. So you can do it that way. You can refer back to that lesson if you want to do it that way to double check to see how this works. But I'm going to show you this way. So we have our first vector is 72 at an angle of 102 degrees. So we have 102 degrees about right here, and this is 72. The next one is 63 at an angle of 152 degrees. So we're looking for this resultant right here. So what we're going to do is make a parallelogram out of it. So this length is 72 over here. This is 63. All right, what is this angle going to be? So this angle right here is 152 minus 102. So that's 50 degrees. So if we draw a straight line, this angle would be 50 degrees. So the remaining is 180 minus 50 degrees, which is 130 degrees. So if we blow that up, we have 72, 63, and then this is 130 degrees. And we're looking for this R. So we have R squared equaling 72 squared plus 63 squared minus 2 times 72 times 63 times the cosine of 130 degrees. Take the square root of that. So our R should equal 122.4. All right, now we need to find the angle. The angle that we're going to be looking for is from the standard all the way to the resultant. So what we might want to do is find this angle up here, because this angle is the same as this angle, and then add 102 degrees to it. So we have 63 over the sine of theta is equal to 122.4 over the sine of 130 cross multiply 63 times the sine of 130 divided by 122.4, and then take sine inverse. We get 23.2. So that's this angle, which is the same down here. You could have just used this triangle. This is 130 up here. And then we need to start from the standard, so we need to add 102 to it. So our angle is 125.2 degrees. And if you would have done this the old way, or the way that I taught you in adding non-perpendicular vectors lesson, you would have got this answer as well. Let's look at another example. Forces of 675 pounds and 828 pounds act on a body. The smaller force acts due north. So due north Smaller force due north, 675. The larger force acts north, 52.3 degrees east. So that means you're going to go north, you're going to go 52.3 degrees east. So this is 52.3 degrees. Now be careful, if it said east, then north, this would have been 52.3 degrees, and then you would have had to subtract that from 90 to get this angle. This is 828. The resultant is in the middle, and then we can extend our parallelogram. So if this is 52.3, this angle is just 180 minus the 52.3, so 127.7 degrees. This is 675 over here, this is 828. So we want to find the r. So we have r squared equals 828 squared plus 675 squared minus 2 times 828 times 675 times the cosine of 127.7. Take the square root. So your r should equal, with 3 significant digits, 1,350 pounds. Now what we're looking for is from standard position to this red line, the magnitude. So let's find this angle. So we have 675 of the sine of theta equals 1350 over the sine of 127.7. Cross multiply and then take the sine inverse. You get theta equaling 23.3 degrees. Now you have a few different options of how to write this. If I gave this to you in cardinal form, which we will go over, we can start from the north. And how far are we going over from the north to the east? Well, this whole angle is 52.3, so take 52.3 minus 23.3, get 29 degrees, and you're going east from there. Draw the following cardinal directions. I'm going to first draw our north, south, west, and east. We are starting north and we're going west. So we're going to go north and then west 62 degrees. So without cardinal directions, this would be 90 plus 62, so this would be a 152 degree angle. The next one, same thing, north, south, west, and east. We are starting south, and then we're 87 degrees west. So south, 87 degrees west. So this is 3 degrees, so 180 plus 3 is 183 degrees without the cardinal. The next example is north 23 degrees east. So north to east, this is 23 degrees. So without, take 90 minus 23, we get 67 degrees would be the angle. Our last example is north 35 degrees west. North 35 degrees. So without cardinal directions, we always start here. So that would be 90 plus 35, so 125 degrees.